All right, let's look at 1D motion problem types. So the first two we're going to look at is position versus time graphs and velocity versus time graphs. So you know you have a position versus time graph because, yes, you have position versus time. It can be a X or a Y on that axis, but time has to be on the lower axis, the horizontal one. If you have a position versus time graph, the intercept tells you about the initial position. So if we're doing the X position, it would be X naught. The slope of the graph tells you about the velocity. The steepness of that slope tells you about the magnitude of the velocity, where if it's sloped up and positive, that tells you about the direction of the velocity, or if it's sloped down, it's negative, that tells you about the direction of the velocity as well. Concavity, how it's curved, tells you about the acceleration. So the sharpness of that curve tells you about the magnitude of the acceleration. If it's concave up or concave down, that tells you about it, the direction of the acceleration. So positive would be up, concave down would be a negative acceleration. If you have a velocity versus time graph, it is a velocity versus time graph problem because you have a velocity versus time graph. The intercept tells you about the initial velocity v naught. The slope of a velocity versus time graph tells you about acceleration. So this is where you have to keep things straight. Which type of graph do you have? Do I have a slope velocity or slope acceleration? Okay, so our velocity versus time graph, slope tells me about the acceleration. The steepness of the slope tells me about the magnitude. If it's sloped up, positive, or down, negative, tells me about the direction of that acceleration. We can also talk about the area under the curve on a velocity versus time graph, tells me about the displacement. The size of the area tells me about the magnitude of the displacement. If it's above or below the axes, tells me if the displacement is positive or negative. So it tells me about the direction of the displacement. Now, up at the top of the green sheet, we don't have like a specific problem type for this, but I'd like you to write it on there anyway. If something is speeding up, we know that because velocity and acceleration have the same direction, or vice versa. If they have the same direction, I know it's speeding up. Slowing down means velocity and acceleration have opposite directions. So you should be able to look at these two graphs and look at maybe the slope and the concavity, determine if they're both positive or both negative, telling you it's speeding up, or if one's positive, the other one's negative, slowing down. All right, let's get the other problem types on here quick. All right, now that we got that set up, so the rest of it, 1D motion problem, it's a 1D motion problem because it's only going in one dimension. Now notice that's the word dimension, not the word direction. It's only going in one dimension, so it can go back and forth or up and down, okay? List your variables, choose an equation. That's what you do when you have a 1D motion problem. So x naught x, v naught v, a and t. If you're in the y direction, it would be y naught y, right? Constant velocity, you know you have a constant velocity problem because it says the velocity is constant or it says the acceleration is 0. If that is true, the initial and final velocities are the same number and the acceleration is equal to 0 meters per second squared, which means use equation number 2. Okay? Free fall, it's a free fall problem because only gravity acts on it. Okay, so if only gravity is acting on it, it's in free fall. That means your acceleration is negative g, where g is the acceleration of gravity wherever you're at. Here on Earth, g is 9.8 meters per second squared. Also, if you see the words dropped in a free fall problem, they are telling you that v naught is 0, so it's dropped from rest. The next one, max height. So if it's a free fall problem, you throw it up in the air, it reaches a maximum height. At the maximum height, the velocity is 0 at that maximum height. If you throw it up and it starts and ends at the same height, okay, so it starts and ends at the same height, therefore it's a y naught equals y problem. So y naught equals y, which equals 0. So we'll choose that starting height to be 0. The final velocity is the opposite direction, but same magnitude as the initial velocity. And the total time, half the time to make it to the max height. All right, simultaneous problems is when we have two objects moving at the same time in the same frame. So if we have that, we need a common reference frame. We need to choose a common x equals 0. The two objects both can't start at x equals 0, so you have to have a common frame of reference. They also need a common time frame. They need to agree when was time equals 0. So a way to do this is if they start at different times, the shorter time is t, the longer time is t plus that head start that the one that's been going for a longer time had. That is your problem types for 1D motion.